Hello, and welcome to my world of conversation around math topics. My name is Amber Soto. I'm the Director of Mathematics for iLead Schools, and today's topic is the Pythagorean Theorem. So my question for you is, what does the Pythagorean Theorem have to do with this Olympic swimmer? Or this one? And in fact, what does the Pythagorean Theorem have to do with any of the swimmers on this slide? Well, you're in luck because I'm about to give you an answer, so buckle up. But first, a disclaimer. This video does not provide a proof of the Pythagorean theorem. There are a lot of other videos out there for that, and I highly encourage you to seek them out. It's one thing to be able to apply a formula, and it's another to really truly understand where it came from, how it was derived, what makes it work, how it connects to other mathematical concepts. So I would encourage you to seek out a proof of the Pythagorean theorem. But this video is simply to give you an easy method that will help you to remember how to apply it correctly. So let's dig in. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the two sides of a right triangle, c is the hypotenuse, and if you were to plug it into this formula, you can solve for unknown lengths on the right triangle. This is absolutely legit. This is how the Pythagorean theorem is generally taught, and if you apply it properly, it's correct. However, as I was teaching, I found that a lot of my learners struggled with what is A, what is B, and what is C. So I started teaching it a different way that would make it a little bit easier, and that is leg squared plus leg squared equals hypotenuse squared. I don't know if you caught it, but hype is hypotenuse shortened. So the other thing I wanted to make sure to point out is that the two legs here, it's not the same. There are two different legs of the triangle. So we'll call this one leg one, this one leg two, and now we can see they're different. It really doesn't matter the order because addition is commutative, but now we know they're two distinct legs on the triangle. So now that we know that, the question is, how do we know what's the legs and what's the hypotenuse? So I have a fun little way for you to remember. If we have a right triangle here, so we know we can use the Pythagorean theorem, I want you to pretend that we grab it and rotate it around until the right angle is up here on the top. And once we have that, we'll lay some SpeedOs right here on top. So this is where the swimmers connect with the Pythagorean theorem. I know I sound like a crazy lady, but just hang with me. All right, then we're going to put some shoes on the feet down here, and we're going to pretend we're going to take a nice stroll through the park. So let's have some grass to walk on. And now that you have this, it is much easier to visualize where the legs of the triangle would go. Here's one of the legs, here's the other, and that leaves the hypotenuse at the bottom across the grass. The hypotenuse will always be across from the right angle of the right triangle. We call this the SpeedO method. It's silly, it's fun, it's crazy, but I guarantee that kids will remember it. So how will we apply this? Well, let's see. We have a right triangle here, and we have 3, 4, and x. We need to plug it into our leg squared plus leg squared equals hypotenuse, so we have to determine what the legs are. So again, we take it and we flip it over so that the right angle's up on top. Here are my SpeedOs, here are my shoes, here's the grass to go for a walk in the park, and we can easily visualize that 3 and 4 are the legs. So we can plug them in. Doesn't matter the order for 3 and 4. Remember, addition is commutative. So 3 squared plus 4 squared equals the hypotenuse, which is x squared. Now we can do the math. 3 squared is 9, 4 squared is 16, so we get 9 plus 16 equals x squared. We can add them together. 9 plus 16 is 25 equals x squared. And then whenever we want to undo a squared, we take the square root. That is the inverse operation. So a square root and a square will essentially cancel each other out, leaving us with the x here, and the square root of 25 is 5. Fun fact, if we have x squared equals 25, technically -5 is also an answer, but when we're dealing with the length of the side of a triangle, we're dealing with positive numbers. So for the content, the positive numbers are what will work for us through these. So let's try another one. If we have an x, a 12, and a 13, we're going to take it, flip it over so the right angle's at the top, pop on the SpeedOs, the shoes, go for a walk in the park, and we can easily see that the legs are 12 and x. So 12 squared plus x squared equals 13 squared. 12 squared is 144, 13 squared is 169. Now to solve to get the x squared, we would subtract 144 on both sides. So 144 minus 144 would be 0, that would go away. 169 minus 144 would be 25. So again, we have x squared equals 25. We take the square root to be able to cancel out the square or to be the inverse. And the square root of 25 again is 5. It happens to be the same answer. I didn't do that on purpose. Now, the thing that I want to point out right now is I gave you numbers that were nice and neat here. But in most of your real life examples, the numbers aren't going to come out nice and neat. You may end up with something like square root of 37. And in that case, depending on what the answer is asking for, you can either leave it as square root of 37, or you can plug it into a calculator and figure out what the decimal would be. In that case, square root of 37 is just bigger than square root of 36, which is 6. So you know it's a little bigger than 6. So that is how we would go about working with it. If it is not an even square root, you will get a lot of those. So be careful, but don't panic. It's normal. With that said, you now should be ready to solve problems involving the Pythagorean theorem using the SpeedO method. Again, I know it's crazy, but you won't forget it. And this is just a little reminder. There are a lot of proofs out there. I'm not going to let this one play all the way through because we don't have that kind of time, but here's a little taster, and do know that there's a lot of other proofs out there. So please take the time to go find one so that you can truly understand where this came from. Okay, with that said, I hope you enjoyed this video. I hope it helps you in solving problems involving the Pythagorean theorem. I hope you go practice right now. And as always, happy mathing.